Welcome to Chemistry Lover. In this video I will be talking about a very important reagent because I am continuing the reagent chemistry part, and our today's reagent is sodium cyanide. So this is a question which I have picked from the GATE exam. Now you can see here you have given one alpha beta unsaturated carbonyl compound along with an aldehyde, and it is important to note that this is not an ordinary aldehyde but it is an aromatic aldehyde. In this case it is the benzaldehyde, and it is treated with catalytic amount of sodium cyanide in presence of DMF. So what will be the reaction? Now this is a very well known reaction, and I guess that you know the reaction, but it is a slight variation of the main reaction. It is not actually the main reaction. And now let me tell you the name of the reaction. This is basically the variation of the benzoin condensation reaction which occurs between the aromatic aldehydes in presence of sodium cyanide. Now let me first discuss about the mechanism of the benzoin condensation, because that is the important role of sodium cyanide as a reagent. And after discussing the details of the mechanism of the benzoin condensation, I will come back to this particular question. So what is the benzoin condensation? From the name itself you can guess that it is basically a condensation reaction, and here it is condensation reaction between two carbonyl molecules, and if we more specify, between two aromatic aldehyde molecules. So let's say we have some aromatic aldehyde molecule like this, and now you have sodium cyanide in your reaction medium. So what first step will happen? So sodium cyanide, here you will have cyanide anion, which is nothing but a nucleophile, and this is the electrophilic center of your molecule. So no doubt this sodium cyanide will attack here to generate this tetra. So basically it is Ar because it is aromatic. So you will generate a tetrahedral intermediate like this. Okay, so this is the first step of the reaction where you get a tetrahedral intermediate. Now this O minus, this will be protonated. Now this protonation, the most likely the protonation step is a intermolecular protonation step, which is reaction with some another molecule of the same, right? So it can take a proton like this. So by that what you will get? You will get this OH, this cyanide like this. Here you have hydrogen, and from the another part you will have Ar, O minus, here you have cyanide, and here you have minus. This you are getting from here, and now this minus, now this O minus can again be protonated from this molecule to give you two equivalents of this OH, this cyanide, and this minus. So you will get, after this step you will get two equivalent of this anion, this carbanion. Now this step can also be intramolecular, that is like a proton exchange between this proton and this oxygen. So you don't need another molecule of the same. So what I am trying to say is that this step can be intramolecular, and by that you will get this OH, this cyanide, and this minus. So this can also occur. Now we are not sure about that whether it is intramolecular or intermolecular, but the outcome is same. Now the question is why this particular carbanion is generating, because you can see normally the negative charge is more stable on oxygen rather than carbon, but here we are doing reverse. We are putting negative charge on carbon and we are protonating this O minus. So why we are doing so? So this is because this is not a normal carbanion. This is a special carbanion which has some special stability. What is the source of this stability? So the source of this stability is this cyanide group. So you can see we can have a resonance structure like this. Sorry, here you will have carbon and here you will have nitrogen. So if we open up this structure, you can see, if we open up this structure, we can have a resonance structure like this. So these two are resonating structure, and this represents that this negative charge is stabilized into this electron withdrawing cyanide group. This is effect of minus R effect of the cyanide group. At the same time, due to the presence of this Ar group, which may be a normal benzene ring, so again this negative charge can also be stabilized into this aromatic ring. So this is why this aromatic aldehyde is needed. If you want to do this reaction with normal aliphatic aldehyde, the reaction will not work. So benzoin condensation can only occur with aromatic aldehydes, and this is one of the reason that you need the stabilization of this negative charge, which can happen into the aromatic ring and not in ordinary aldehyde. So this is the reason. So we understood that why we are getting this carbonyl. Now what is the next step? So the next step is you will have some molecules which are unreacted aldehyde molecules. They will be also present in your reaction medium, and now this, when this O minus push back, it can attack over here. This is same like the aldol condensation or aldol reaction, or like the Claisen ester condensation reaction. The step is like same. And then what you will get? So you will get O minus over here, hydrogen over here, and here you will have, so this Ar group, this cyanide group, and this OH group. Right? Now the next step, what can happen? So in the next step, you can see this oxygen can push back its lone pair, and this cyanide can go, because it is still now it is a tetrahedral intermediate, because this is a leaving group, and once you have a leaving group in a carbon, and the same carbon is attached to some OH group, that is basically a tetrahedral intermediate which is not stable. So this thing will happen, and this tetrahedral intermediate will collapse, and you will have carbonyl group over here, you will have Ar group over here, and now this oxygen O minus will somehow be protonated to give you this product. So this is called benzoin, and that's why the name of the reaction is the benzoin condensation, which is a very famous reaction. Now if you understand the mechanism of this reaction, let me go back to the original question, which was, so the question was like this: you had some alpha beta unsaturated compound like this, you may have substituent over here or not, that doesn't matter, you need this framework, and then you had this benzaldehyde. So when you treat this with cyanide, basically sodium cyanide, what will happen? The sodium cyanide will attack over here to generate this first, this O minus, this hydrogen and this cyanide, and then you will have this proton exchange between this hydrogen and this oxygen. So you will get this minus over here, this OH and this cyanide. Now you don't so if you didn't have this molecule, then the aldehyde it will react to some another aldehyde molecule, but as your reaction mixture contains this particular molecule, which is also an electrophile, and you can see there are two electrophilic center, one is this and one is this, so either 1,4 or 1,2 addition can occur. Now what will happen, that you have to decide that whether 1,2 addition will occur or whether 1,4 addition, that is I'm talking about whether it is a direct 1,2 addition or a conjugate addition, that you have to decide, and you can decide it by looking into the nature of this carbanion. So we have seen that this negative charge is delocalized into this cyanide as well as this aromatic ring. So this delocalization makes this negative charge softer, that is it is a soft nucleophile, so it will attack on the soft electrophilic center, and in this molecule, this alpha beta unsaturated molecule, this is the soft center, so it will attack over here, and by that what you will get, so you will get O minus this, and here you will have this OH, this cyanide, and this pH. And now when this O oxygen lone pair will push, the cyanide will go, and here you can see this tautomerization can happen. So ultimately you will get this product. So this is the product of your reaction. This is the answer. So I hope that you enjoyed the video. If you like this video, then give a thumbs up, and if you want more videos like that, then don't forget to subscribe this channel. Thank you for watching.